Hello, I'm Ruby. In this video, we will see what isotopes and isobars are. To understand the concept of an isotope, we need to know how to represent atoms by their atomic number, mass number, and chemical symbol. Additionally, we need to know how to calculate the number of protons, neutrons, and electrons in atoms. We will draw these hydrogen atoms using Bohr's atomic model. But the most important thing is to determine the number of protons, neutrons, and electrons in each of these atoms. In all three atoms, the atomic number is 1. Therefore, they have 1 proton in their nucleus. It is important to highlight that they are all hydrogen atoms because their atomic number is 1. Now, we subtract the atomic number from the mass number. This way, we find out the number of neutrons the atom has. In the first case, we have 1 minus 1, which gives us 0 neutrons. In the second hydrogen atom, the subtraction is 2 minus 1, so there is 1 neutron. And in the third, it is 3 minus 1, so there are 2 neutrons. The number of electrons in an atom is equal to the number of protons. Therefore, each of these atoms has 1 electron. Let's vertically reorganize what we just did. These atoms are isotopes of each other. We can see that these 3 atoms have the same number of protons, but a different number of neutrons. This is what makes them isotopes of each other. The same number of protons, but a different number of neutrons. And we can easily detect them because their mass numbers are different, but their atomic numbers are the same. In the case of hydrogen atoms, each isotope has its own name. Hydrogen 1 is protium. Hydrogen 2 is deuterium. Hydrogen 3 is tritium. The most important thing to keep in mind when talking about isotopes is that we are dealing with the same type of atoms, but their masses are different. Let's look at another example with carbon atoms. The number of protons is 6 for all of them, but the number of neutrons varies: 6, 7, and 8 neutrons. Again, the number of protons is the same, and the number of neutrons is different. We also see that the atomic numbers are the same, and the mass numbers are different. Carbon isotopes are called carbon-12, carbon-13, and carbon-14. Let's look at the concept of isobars. We have, for example, nitrogen-14 and carbon-14. We can see that the number of protons and neutrons is different in both cases. But when we add the protons and neutrons, we get the same mass number for both atoms. What characterizes isobars is that their mass number is the same and their atomic number is different. Another example of isobars is argon-40, potassium-40, and calcium-40. If we determine the number of protons, neutrons, and electrons, we see that the number of protons and neutrons is different, but if we add them up, we get the same value. Therefore, their mass numbers are the same. Remember that to identify isobars, we need to see equal mass numbers and different atomic numbers. In the next video, we will see the meaning of atomic weight. See you later. Bye.